Welcome to Pratidhwani, where we try to humanize science. I am your host, GV Pawan Kumar. It is my delight and pleasure to welcome my dear friend, colleague, Professor Shivprasad Patil. Shiva, as we call him, is a professor of physics at Indian Institute of Science Education and Research, Pune. Shiva has been an academic for several years now, more than 15 years or even 16, 17 years, and he's been one of the formative faculty members at IISER Pune. His research interest mainly is associated with combining nanotechnology with biotechnology in a way, and also biophysics to a large extent. Shiva has made excellent contributions related to experimental nanomechanics, which is a fascinating area, which we're going to also discuss a little bit more from a viewpoint of force spectroscopy, especially the atomic force microscopy, with a specific concentration towards probing phenomena at a single molecule level. So, if you have a biological cell and you want to pluck that biological cell on top of it through a molecule, Shiva does that, and his lab has been an excellent lab to learn these techniques, innovate these techniques, and he's an excellent experimentalist. I have benefited a lot by interacting with Shiva, a great learning experience. And I'm so delighted to have Shiva on Pratidwani this time. Welcome to Pratidwani, Shiva.
Thanks, Mohan. Thanks for having me.
Yeah. Shiva, give us a gist about your origins. Where were you born? What was it, your kind of background which brought you to science? Give us a gist of that.
Yes. So I was born in a small village near Kolhapur. This is a small village between Sangli and Kolhapur, the two district towns. And so this was in 70s. I went to a school there in my village, the Jilla Parishad school that typically, all villages in Maharashtra have these schools, very nice schools back then. Uh,
Hmm. Hmm.
and then, yeah, so I finished my 10th from my village, and then that's the first time I got out of village. And I never sort of went back to stay there for longer than maybe week or so. So after that, I joined a college in Sangli, the college called Willingdon College. And so yeah, so this is how it started. And my interest in science, if you really are going to ask this question, is started when I was in 10th. I think something around 10th. And this, as usual, teachers are most influential in deciding the career choice in general. And we had fantastic teachers. So back then, in a small school like that, we did a lot of experiments. Experiments such as walking hydra on the somersaulting hydra under the microscope. We took out sodium and see how it catches fire, and this kind of experiments which were fascinating. And my initial interest was in chemistry, actually. When I was in 10th. Of course, because this is again due to a set of teachers we had for chemistry back then. And interest in physics started developing around 11th and 12th during those. And that's where science is taught full scale when you choose science as a, as a 11, 12th, you choose either art or science. And if you choose science, this is where this is taught in a real depth. And that's where I started having interest in physics. Uh, but I mean, of course, you become a scientist, and you always say that this was very early on that I decided to be a scientist. But I think this wasn't the case, because many times this interest also sort of kind of diverged in many other areas.
Hmm.
Wanted to do many other things, but science is something always pulled me back, and I finally focused on doing this. Yeah. So
Fabulous. So,
12th, so
s-
after 12th, I had this choice of doing engineering or medical, because that
hmm,
is typically done back then. I don't know how it is now, but back then it was either engineering or medical
yeah.
that you go for. And I could get admission in one of the prestigious engineering colleges in the town there, called Walchand Engineering College. But I decided against joining there, and I took admission for BSc. And also back then we had I also I particularly I didn't know that there's options like IITs. I came to know about IIT after passing 12th. Okay. Information wasn't available back then. And
True,
after
true,
12th,
true.
I realized, okay, I could have written those exams. So, but then I then continued in BSc. Again, we had really nice teachers in BSc, which could keep the interest going. That is very important, because you are strongly interested in something. If there are no mentors and teachers to guide you, then the interest really doesn't shape into anything significant. I think I'm really glad that I had kind of teachers in my school and college days. And that's how
Mm.
this whole thing began in a way. Yeah.
Fabulous, fabulous. Shiva, given that you actually grew up in a kind of a rural part of Maharashtra,
Yeah.
and compared to other states in India, Maharashtra actually has relatively, good facilities even in the rural areas.
Right.
But there is also a different way of looking at the world when you grow up in an environment which is natural, which is probably also, so to speak, closer to the earth, down to the earth.
Yes.
It gives you a very rich experience of life.
Yeah.
And I've also found that people who may have kind of had their formative years in such places generally also have very good appreciation of working with their hands, because I know for sure that you are one such
Yes.
person.
So I think,
Because Can you tell us a little bit about that influence, if at all there was? I don't know whether there was an influence of that kind, because going to a field, going to a farm is a very straightforward thing in such kind of an environment. Whereas in cities, of course, it is a
right.
celebration sometime.
Right.
Uh, could
Yeah,
you
yeah.
please tell us a little bit about
Yeah. So, yeah, I think, of course, we had a farmland. We still have it, and
it?
still keep interest in farming. But back then, I mean, till 10th, at least, we used to go to farm every weekend, and I know how to plow. I
Mm.
know how to, take care of animals, for instance. And
Nice.
what you said is very important. And this is where the first time I learned to work with hands. I mean, I guess
Mm.
this is something that you do not, maybe if you are a kid in the city, this opportunity is not kind of offered to you. Many good schools nowadays are sort of bringing that element into their curriculum, but
Mm.
this was very natural to us. I mean, this was also, going to the well, taking out water from there and working on farm. So all the entire summer vacation was on the farm. We didn't do anything else. So this was fantastic, because this is how we first sort of started working with your hands, and that this was not a problem for me when we start to sort of learn things, and we were working in the lab. Handling things was not very difficult in a way. Second important thing about growing in a village is that you do not have these pressures. As I told you,
Mm.
I heard about IITs when I passed 12th, and I think we had no pressure of any kind, to excel, to do this, to do that. And till 10th, I remember I was equally interested in all topics, all subjects, and particularly I was interested in Marathi literature a lot. And very early, maybe around 7th, 8th, I was sort of deciding to become something like, a student of Marathi literature or literature in general. And
Nice.
this really kind of became science in 11th, 12th, of course, and 10th. But then I think the village atmosphere sort of is natural, and uh, the parental pressure about becoming something, something that they are proud of,
Mm.
is not there. And I think that makes a big difference growing up, if you are in the environment like that. Yeah.
Yeah, it's such an important aspect of it, and also this connection to one's mother tongue is such an important thing. In fact, it's actually one of the very kind of very interesting thing about growing up in India, right? Because
Yes.
all of us, our mother tongue is not English,
Yeah. Yeah.
and most of the things what we actually do has a framework which is anchored in English, at least as scientists most of
Right.
the time.
Right. Right.
But there is also inherent, rooted cosmopolitanism, some kind of a interesting anchoring what you generally have. This rooted cosmopolitanism. Of course, there is a lot of people, historians, a lot
Sure.
of people do talk about. Even journalists also talk about this. That anchoring brings in its own flavor, because I know
Right,
as
right,
we go along your journey, you'll see that it actually has even broader kind of connections because you lived and worked in Spain and US and other places too.
right, right.
I'll come to that. But give me a gist about this because I know, yeah, you and your family also is deeply kind of interested in Marathi literature and also the cinema. I know that's something I'm very very keen to connect to. I should
Right.
mention that Shiva's wife is a Jayanti. Is an outstanding artist. In fact, we all adore her artistic principles. Especially, she's a great artist who paints and does a lot of things. All our kids also learn a lot of things from from Jayanti. So in that particular viewpoint, Shiva, I just wanted to get the gist because that anchoring to language, that is sometimes missing in science, and we may have to also do that, right? Somehow we have to bring science and the language what we speak, which
Right,
has not happened unfortunately for a very long time. That's one of the lacking elements of our education,
right.
so to speak. Yeah.
Yeah, I think this is a question that linguists also debate, right? When
Mm.
you speak in a language, but you think in which language?
Mm.
I guess it's not only a communication device; it's also a device that is used to have a dialogue with yourself. And in that respect, I guess it's nice that we learn in Marathi medium, and I still have a thinking habit in Marathi, and this is quite important. And I guess um, uh, the point is that in schools, even in our times and today, languages are ignored, uh,
Mm.
really, and this is something I feel very strongly about. Uh,
Mm.
because your growth in a given field, be it science or doing business or be it art or doing art or whatever, after a point, it's the languages that sort of take you further than a point.
Mm.
And if you're not used to sort of have this dialogue with yourself in your own mother tongue, I don't know how people when they think, I don't know how you think, Paul. You think in your
Mm. No,
language,
no, no,
you
I
think
agree.
in English, which is the language that we speak every day. Almost all of us spend majority of our time, or big chunk of our day's time speaking
Mm.
in English. But when we think, actually, we do think in our own languages, I feel. And I think even scientific problems, even when I am really trying to understand a complicated research paper, let's say,
Mm.
and I go away and start thinking about what is it that this paper is saying. After a point, I find myself debating this and talking about it to my
Mm.
Marathi. So I guess this is important, and I really envy the Western researchers, such as like
Mm.
UK or Germany, for instance. And I think it's the language they communicate in and the language they think in is one and the same.
Mm.
I
Mm.
think it really makes a big difference. And
Absolutely.
it's, I mean, I don't know how to, if you start saying then let's have all the science and art and everything in our own mother tongues.
Mm.
Is probably we are in a situation, this is also not practical.
Yeah,
I
yeah.
don't know how to put this, but that would have been ideal. I guess somewhere around we got independent, we also decided to have linguistic states. But these states individually never put in enough effort, I feel, to bring this important text of technical knowledge, of science. There was not serious effort to put that into our local languages, our
Mm.
Indian languages. I mean, hardly any Indian language can boast of having scientific texts, or let's say, for that matter, any other text to the level that we find in Western languages, particularly in English. And I think it really makes a difference. It would have been really nice for all of us
Mm. Mm.
think and do work in the same language, but this doesn't happen, unfortunately. And
Absolutely. Such an important point, what you're mentioning. In fact, that lexicon, that's what, right? Because that is the crucial element. And if you look at various different countries, non-English speaking countries, for example, Japanese, it seems they took a lot of effort to ensure that technical terms actually have been
Yes.
translated into their
Yes. The
everyday
whole
life.
text, whole books are translated
Yeah.
into the languages.
No, in fact, I personally I feel, for example, it really is disheartening because very classical languages like Sanskrit
Yes.
has not even become, leave aside the technical aspect, it has not even become the language of communication.
Yes.
Now that's actually disheartening because it has a rich kind of texture and there's so much beautiful literature
Literature.
which is there. And
Not accessible to us anymore. I mean, this is
exactly, it's a
sad.
shame, right? Because it's a very unfortunate thing that there's so much of things which can be going on. Okay, moving in your timeline, Shiva, tell us a little bit about how did you now transition from your schooling to your undergraduate? Tell us about that transition and how did it happen? What are the things you did?
Yeah. So after 12th, I decided to join BSc. There were no IISERs back then, right?
Yeah.
Not to be engineering colleges in a way. So I did started BSc in Willingdon College in Sangli, and once again there were Professor Bodas, Professor Deshpande, and they really were very good physics teachers. I still
Hmm.
remember learning quantum mechanics from Professor Bodas and electrodynamics from Professor Deshpande, and they were really a strong influence on me to they were the first ones to tell me that okay, fine, there are these institutes called IITs, and maybe you should
Hmm.
after finishing BSc year get out of this place and go there if you really want to do science and do career in research. So I wrote the exams, of course. Then by the time I finished BSc, Rasnik holiday, we then I
Hmm. Yeah,
but I
yeah.
got it and I solved all those problems from the
Problems, yeah.
two books. The time was that I then took an exam from IIT Bombay for the masters, and unfortunately, the other place that I wanted to go to was University of Pune,
Hmm.
and these two places had the entrance exam on the same date. So then I decided to go to IIT Bombay and I gave that exam, which I didn't clear. I didn't get into IIT Bombay. And so I also missed the opportunity of Pune University. So it seemed. But thankfully, I topped the university,
Hmm.
Shivaji University in physics. I was the topper. And Pune University had a rule, and this is just a tiny little window, right? To get into
Get
something.
it.
And the Pune University rule said that all universities from Maharashtra, the toppers can directly take admission into their master's program.
Oh, wonderful,
And when
wonderful.
I heard about this, I was relieved because I know that this is something that really saved me
Yeah.
because it was really kind of I didn't know what to do further because Shivaji University had a master's physics program, but it wasn't something that will shape you into becoming a researcher, let's say.
Hmm. Hmm.
So I got into Pune University, and you obviously know that, of course, you know that Pune University in our times was really it was great. The professor like Sivendra Madhikari, with whom I did PhD later,
Yes, yes.
Sogle, Professor Kanire, I mean, you name it, so many people. And this is the first time I saw, people doing research, how they do it,
Hmm.
what are the labs, what are the tools and techniques, and how they go about doing this. And this was really nice. So it's my second year of my master's. And of course, it was very cosmopolitan atmosphere. Pune University, there were students from Calcutta, and they had in their bachelor's. University of Calcutta was, famous for physics, and what they had learned in the bachelor's, we were not even had not even reached what they had mastered. So many things. It was also experience in a sense. There you were a topper in the university, and here you struggle to pass. So this was good in a way. And in the hostel we stayed up long hours, talked, discussed physics, and there were also other students who influenced me. I mean, Nisim Kanekar was our senior. There were
Yes,
others,
yes. Yeah.
and many faculty here that from University of
Yeah, yeah, yeah. They have so many
Yes,
of them around,
yes, yeah,
including
yeah.
IISER Pune, Mayuka, and
A
many
lot of
other
people,
places.
and this was really vibrant, and this is the
Yeah.
atmosphere I wanted to be in. This was something that I really kind of, and this happened by this chance event that if this rule wasn't there, I really thank the person who made that rule. And then in the masters, I did the project in. This is the first time I.
Mm,
Of course, in Willingdon College, we had a long list of experiments. Some of the experiments we did were really fantastic. Measuring temperature of a flame. Like I still remember those things, ballistic galvanometers and those things. And this was nice. And Pune University took it to another level, of course. And in second year of masters, I did a project in field emission microscope
mm,
lab, and this was the first time there was an introduction to ultra vacuum techniques. I made my own tube, sealed it from the machine shop, and there's a phosphorus that we had to coat to get the emission. And it was such a joy to have the field emission thing that you could see a pattern. And that was the first time serious
mm,
introduction to building instruments and doing something with your own hands. So yeah, so the masters was done, and then was time to again. This the everyone does this, right? Take a tour of India.
mm,
All the research labs from Bhubaneswar to Madras. So we went, all of us, a lot of us, and I of course cleared the CSR exam at the very
mm,
first attempt, because of we together, eight of us in one go, all up in our class. And back then, the CSR fellowships were not too many, but
yeah, yeah.
eight of us cleared it in one go, and it was really nice. So we went around, went to ISC, to TIFR, to Bhubaneswar, IOP, Physical Research Laboratory in Ahmedabad. So we did this journey of Indian institutes to get into, to do the
Mm,
PhD. Unfortunately, I couldn't clear any of these interviews. And somehow I was, I don't know, I was nervous, not
mm,
really stressed that, what if I do not get into this place. And since I had fellowship, I then decided to go back to Pune and join Professor Dharmadhikari's lab.
mm,
I remember I went to him and said, "Sir, who is to say, sir, I didn't get anywhere, so I would like to join your lab." And he looked at me and said, "This is not a good idea. Not because you didn't get anywhere else. It should have been your choice first." And I felt really bad. I still remember, you know, in front of me, and he's saying that, okay, I mean, not because you didn't get anywhere else, you're coming here, but we are doing as good as anywhere else. And this
absolutely,
was, one of these things with Professor Dharmadika I learned was this, in the attitude, that
absolutely.
and I really thought, yes, indeed, because he was building the first scanning tunneling microscope of the country. In 80s, the STM was invented,
Yeah,
and 5 years after the instrument was invented, he dreamed as big as making it in India. Something
absolutely.
done in IBM Zurich, and only places like UCLA and big labs in Western countries were interested in this. But he in Pune University sort of decided to do this. And what he said made absolute sense, because it should have been his lab that should have been my
Hmm.
first choice in a way. And I joined there, and this is really those 5 years were really wonderful. I mean, I learned everything from Professor Dharmadhikari,
Mm,
how to sort of make this nanomechanical, kind of piezoelectric crystals, how to make connections on them, how to make them move, how to sort of go from millimeters to nanometers, these
mm,
actuation things. Everything was done in his lab, by hands. There was nothing that was bought. There was only one oscilloscope. That was the old computer. Of course,
mm.
this computer and oscilloscope we shared among students. So I used to do experiments after 2 o'clock till late in the night, because morning, 8 till 2, someone else was using the oscilloscope. Can you imagine?
Nice,
you know
nice.
so this was really nice. And so we built within 1.5 years, I think, after me joining there, we built the first AFM in India. And this AFM then, we published 4 papers in my PhD using that AFM, and very quantitative, nice stuff. And I was looking yesterday; those papers have citations to the tune of something like 50, 60, which is not
Yeah,
bad.
yeah.
Uh, with the hand built, home built instruments and everything. So yeah, so this was, and I think another turning point I would say was in this um, in third year of my PhD. Professor Dharmadikari was invited for a talk in Germany, in Münster,
Mm.
a conference called SXM, which is a scanning anything microscope. That was the time of
Yeah,
making so many microscopes out of scanning probe techniques.
yeah, yeah.
And, he couldn't go for some reason, and he asked me, "Can you go and give this talk?" And it's a third year of PhD, right? I mean, I mean, you're not
Yeah,
so.
yeah.
I said, "Yes, why not? I will go."
Mm.
And but then there was a funding problem. I got half the money from the conference organizers, half the money CSR gave, and then I managed to go there. And this was nice. On the in the conference, I met the inventors of AFM, okay, and STM also, of course. And Christoph Gerber, who made the
Mm.
first AFM himself, he's the professor in IBM Zurich, he's the engineering mind behind
Mm.
AFM STM. Although the scientific ideas was Binning, Quet, Gerber, Binning, Quet, and others. He was the one who actually built the instrument. And I not knowing what to say, what to do, I went up to him and said, I have built an AFM in India. So there were people in the room, okay,
Mm.
a lot of talk going on, and he held my hand, took me outside, and he said, "Say it again." And I told him, "We built AFM in India." And he was fascinated. He said,
Mm.
"Just tell me everything." And he
Mm.
then I explained to him what all is done. And we made the cantilever ourselves in AFM, because back then
Wow. Mm.
nuclear tests India had conducted, and there was a
Yeah, there's
Japanese
sanction restrictions.
yeah,
Yeah.
and I couldn't buy cantilever. So I made my
Is it
AFM,
not
but
even a cantilever? Huh?
oh, no, no cantilever.
Mm.
So AFM is all ready, and I'm sitting in the canteen and waiting for this cantilever to buy from somewhere. And this is not happening. So then I took out the first paper, AFM paper, and I went through it and realized it's a gold foiled. Went to the went to a goldsmith shop and bought a piece of gold, half a gram or something, made a long wire out of it, made it very, very thin, and you will be surprised. This was so thin, that wire, it was 20 microns. The
Oh.
goldsmith pulled it.
Mm.
It really did that. I took that wire, flattened it with a high pressure rolling vice, and then we cut it into parts, and the cantilever was then. And we put uh, a small particle of diamond that we found from this faceting. People do faceting, diamond faceting. A lot of
Mm. Mm.
that falls off. You can actually find that they are very sharp. You pick one of them and glue. This is exactly what the first AFM was.
AFM, yeah.
I was following their paper. I told all of this to Christoph Gerber,
Mm.
and he was so fascinated. He said, "You are coming to IBM Zurich." And we were in Münster in Germany, and
Mm.
I was like third year of PhD, right? I said, he said, "Can you come?" I said, "I will come, but in Switzerland required visa then."
Visa. Mm.
Which I can. And so I said, "I don't have visa. How can I come?" So another very important person in force microscopy, Ernst Mayr, he talked to Ernst and said, "Can you arrange an invitation letter for this young man?"
Mm.
Ernst Mayr wrote to his secretary back in Basel, and she faxed the invitation letter to the conference venue. It was in a hotel, and I had the invitation letter. I went to IBM Zurich. Can you imagine?
Wow.
So and then I spent a week in Basel with and I was lab after lab. I was looking how people are working. And the Basel University, is one of the top universities in the world. And I saw people working with the hands. There were electronics everywhere.
Mm.
The labs were like a playground for them. And this is something that was left a very good impression on my mind. This is how science is done. This is you don't wait for big grants to come, big instruments to materialize. These people are building everything. And also I remember as engineer there in the machine shop was showing me a piece of electronics that he had built, and he said, "This is going to the space. They're sending AFM to space." And he said, "I am building the electronics for it," and he was explaining. and also met a lot of Nobel laureates in IBM Zurich,
Yes, yes,
scientists,
yes.
superconductors, and all that. And it was so nice to, as a third year PhD student, who gets this opportunity. And I think I was lucky. It's just because Professor Dharmadip couldn't go, I said yes, and one thing led to another. And I
Uh,
went to Basel, and spent a week there. Then I went to IBM Zurich, spent 2 days there, and this was really amazing. So yeah, so
Fabulous.
yeah, and then and another important thing, Christoph Gerber, he took me to his room and said, "You didn't have cantilever, so you made your own gold cantilever." And by then, cantilevers were microfabrication process.
Mhm,
People quickly realized that this bulky, massive gold
mhm.
cantilevers were no use, and you have to make the mass very low in order to have good time resolution and good properties in generally for the force sensor in AFM. And he said, but now no one is using gold cantilever anymore. So, and he gave me a one big, 350 cantilevers,
Wow.
one wafer, one round 2-inch wafer, and
So
cantilevers on it. He said,
your PhD is done with that.
absolutely 350 cantilevers on that wafer. I said, take it. I said, but this, I didn't know what to say. And then I got those cantilevers back, and then we design our AFM, other things around it. We then started doing tapping mode AFM, started
Mm,
oscillating these cantilevers because the gold cantilevers were not really good for that. And we started imaging also. We imaged optical grating, and my thesis last
mm.
two chapters is actually all of this is implementing imaging, because before that I was just doing force measurement, because gold cantilever, that's what all one could do with. And yeah, so this was nice. And yeah, so my PhD was done in 2003. So
Fabulous.
uh,
Fabulous. So I have to mention to the audience two things. One is, of course, Professor C.V. Dharmadikari. People should know more about him, especially this within the scientific community. He is one of the pioneers in scanning probe microscopy, where his lab actually has built one of the first, scanning probe microscopies, and probably one of the first in the world. It's like if you take integrated it
yes,
over the whole world, there are very few groups who indigenously could build this. And CVD's group, as we know, him were the pioneers. I know also personally Professor CVD because he was our visiting faculty at our department at
yes,
IISER Pune, and it's an absolute pleasure to having known him, and also learning a lot of things. Excellent teacher. Our laboratory programs have vastly benefited thanks to Professor CVD, and his contribution has been outstanding, so to speak. And you could see also the legacy what actually is felt in Shiva's
yes,
work and other places. He still comes. Professor CVD still visits us sometime whenever he's free, and the kind of that you could see that hands-on kind of knowledge. It's using brains and hands in one go. I keep telling that that's a beauty about experimental physics or experiments per se, for that matter, because you need to really think not only here but also through hands.
yes,
And that's something which I also really like about Shiva's work. I should mention that there is something very, very fascinating. So Shiva, the other part is, the IBM story, what you mentioned, it's fabulous.
yeah,
I also, had the exposure in the near field optics, as you know, because
yeah,
that is the IBM, Aditya Pool was actually one of the
right,
pioneers
right,
there, and Lucas Novotny also, and Alexander Boilier, who
yes,
was here at IISER Pune a few years ago, who is my friend's collaborator. And he was one of the last students of Aditya Pool
right,
and who did his PhD. So this is a great community, but that there is also that great spirit, Shiva. To it's a kind of a different kind of sociology. Each particular subgroup of science has
right,
different kind of sociology, and you have been in this community for a very long time. You now also organize conference called Conforce, which I'll come to later on. Uh, so give us a gist about this part of community. How do you feel being in such community? What are the overall lessons? And then we'll go further into your career. Yeah.
yeah. So in terms of belonging to a community in science, we
Mm.
always belong to a community,
Yeah,
right? In a way.
yeah, yeah.
And here I belong to a community of people who do instrumentation in
Mm.
probe microscopic techniques. And there are conferences around the world that are small in number, like 100, 200 people is the big conference. And typically the what we organize is 50 or so. And what I like about this community is that they are extremely careful about precision measurements, and they exactly know what they're measuring.
Mm.
Many times this becomes one of the problems in science, is that if you're not fully aware of what you're measuring, you don't even know what are the things that are contributing to your measurement.
Mm. Mm.
How is it that you want to separate these contributions and really get to the quantity that you wish to
Mm.
measure in the end. And so be it STM, be it AFM, be it nanomagnetic Hall probe effect at a tip sample level, at a nanometer scale. Our community is, and also there is a community of nanotribology people who
Mm.
worry about the nanomechanical contact, because that's of utmost importance in tribology, because that's where the loss in energy and everything starts
Mm.
starts to happen. So all these people uh, are they not only making cutting edge measurements, but they're fully aware of what are the problems, and what all can we do, what are the issues. The simplest of the problems are yet not resolved in probe microscopy community. And all of these are still debated. And so this community also has a very strong interface with industry.
Mm.
The
Mm.
sense that all the AFM companies, that I mean, many of these people have started their own companies, and later on they become big and merged with some other broker or some other big companies. But to begin with, all AFM companies and STM companies have been started by people who built these techniques in their lab, and then went ahead. So it's a nice in a way that we are really very, very quantitative in what we are measuring. And it's just not a tool off the shelf for us. So also you'll probably see this for NMR community as well, I guess, in a way that the people who have been developing these tools, and they exactly know what they're doing. I think that is something that I really like being in this community, because many times when papers come for review from other people who are not from the community, let's say, and those who have spent enough time with AFM, STM, and these things, and you can see the difference in quality of science that is coming out of
Mm.
these labs, as opposed to labs which use this tool as one of the many, and off the shelf. So that's quite, and I guess I slowly just through PhD I was in instrumentation, and naturally then I when I got the first postdoc offer in USA. This was to build another instrument very similar to AFM, interferometer based AFM. And so I guess from that time on, it's always been like this. After joining IISER Pune, also we built about several instruments for different purposes, not only to do single molecule for spectroscopy, as you mentioned earlier, but many things that we have built ourselves. In my lab, 7 instruments we have built so far, and the different versions of it. And I think this is a really nice way of doing science. One important thing is that you don't have to spend too much time in writing big grants.
Mm. Mm.
I think this is very important, and you can still your science is kind of safeguarded from fluctuations in funding scenario, let's say. So the funding scenario is always like, the thirst areas. Some time
Mm.
ago there was a nanotechnology. Today there's a quantum technology. Tomorrow there'll be something else. So if you really want to pursue your interest, it's a good idea to have this ability of toying around and building your own instruments. You can still make good impact in terms of research, I feel.
Absolutely, absolutely. In fact, that's such an important point what you're mentioning, because it should not curtail the momentum, so to
Yeah.
speak, and because your ideas, the rate at which ideas can come in your mind and you can execute them,
Yeah.
There is surely a gap always, but funding should not be generally the main reason why this
Right.
realization doesn't happen. In fact, historically, that has been an issue in India. That's right, because you look at the kind of ideas a lot of scientists have had, going back, even not just only theoretical ideas, even experimental ideas.
Yes.
Take for that matter, even ISRO, for example,
Yes. Yes.
it's actually an engineering marvel because to do that with all the constraints, that one really doesn't appreciate the
Right.
how much thinking has to go,
Right.
because it's an optimization problem, and optimization problem is not an extrapolation problem. It
Yes.
needs a
Yes.
lot of
Yes.
and kind of
Right.
almost lateral way of thinking, and such an important aspect of it. Yeah. So, Shiva, with this kind of experience and with this kind of training, what you got, how did you now evolve post kind of PhD? What are the things you did? Tell us a little bit about
Yeah, as I said, we went 2 years for first
that.
postdoc, then went to
Mm,
Spain for the postdoc, and everywhere this has been building another
mm.
instrument in a way,
Yeah.
and that was good. And yeah, so one day it's always like, I was telling my PhD student the other day, Ajit, who came to give a talk,
Yeah,
that
Ajit. Yeah,
he said, "What's the good time to sort of apply?" I said, "It
yeah.
is like getting married, you know. You know exactly when do you want to have your own lab, you know. So exactly like you realize, now I should get married." So told him the time will come, and you cannot probably live in your mentor's lab forever, and you will feel like having your own lab. And this is the kind of feeling I got in 2007 or so. And although my postdoc mentors were planning something for me that we should be in Europe or USA and apply everywhere, and indeed I did apply everywhere later on. But after doing all those applications, I just packed my bags one day and came back without really
Mm,
having, like everyone does, make sure that you got a job back
mm.
home, either IIT, IISER, and then you make that move. I
Yeah.
did quite the opposite. I applied, yes,
Mm,
but just applied. There was no
mm,
response from anyone. I came to India and I was here for a month or so,
mm.
and then IISER Pune called me inside Trinity Building, as you probably
Yeah,
remember.
yeah.
And I gave the talk, and this was also the day where selection committee also met later on
Mm,
after my talk was given, and they were quite happy with everything. So and then Professor Ganesh was the
mm.
director, and he asked me that everything looks okay, and we'll give you a offer letter soon. But when can you join? I mean, they thought maybe I have to go back and tell my postdoc mentor that okay, and no, everything. I said I can join tomorrow, no problem. This
They
is
would be shocked.
so I guess yeah. So this is again, as earlier you said, no, about this staying close to
Yeah.
your being coming from a village. I think I didn't worry about all of these things because
Mm,
I said going back to India, you'll get a job. If not, you'll do something anyways. And as long as you are able to put your mind to something, something
mm,
will work out. And because our parents were not pushing us into,
mm,
you have to become this and that, this kind of thinking was possible, even, let's say. So I joined IISER Pune, and this is where I first time, let's say, with influence of Shashi, he was
mm.
the biology chair then, and I met
Professor Shashidhara, Professor
Shashi
L.S.
Dharan.
Shashidhara, yeah.
Yeah, yeah. And so this is where I first applied for Welcome Trust DBTs,
Mm,
and I had did not know anything about biology, not even biobiology, let's say.
mm,
And I went there for they shortlisted me for some reason. I went there and gave the talk, I gave the interview, and biophysics was something I wanted to do, but I had no
mm,
clue what this topic is, what biology is to begin with. And they realized that I have a good potential, but
mm,
nothing from biology. So they said, "You come back again." And after a year or so, they made an exception to allowed me to apply because you could apply only once. But then they
mm,
made an exception, and I this time I did study biology, talked to a lot of our biology friends, and looked at biology texts. And this time we would get the grant for biomedical research. And this is another turning point, let's say, in my
mm,
scientific
mm.
journey where I now started thinking about biology problems, let's say, and biophysics problems. And once a physicist, always a physicist, as we you know, right? We are looking at everything from the physics viewpoint. And nowadays, I'm beginning to realize that this is not working, all the time. So, but still, we trying to look at this. And since in my PhD and postdoc, uh, mainly my interest was in precision measurements. And
Mm,
I quickly realized that this is something that is lacking in, in general, soft matter and biophysics, because everything is at room temperature. Unlike our condensed matter friends, hardcore condensed matter people, they can take the temperature down to millikelvin, and
yeah, yeah, yeah.
that's a hard thing to do. I do understand, but once you're done that, whatever comes out is a clean physics, right? We
Absolutely.
don't really worry about that. So that's not same thing in soft matter and let's say
Yeah.
biophysics, where the temperature you can't get rid of. This is something that it stays there. It is always there, and you have to work with that constraint. And as a result, you could push measurements only to the thermal limit. Right?
Mm,
For instance, if you're making force measurement, you pick up a cantilever or optical tweezers. You can't get away from the fluctuations that are thermal, and so your measurements are limited by what is allowed in thermal limit. And that's where I think that's one reason, I guess, precision measurements were not very popular in soft matter and biological physics.
mm,
For instance, we measure storage loss modulus and rheology and all of that, and measurement of viscosity. But going down to the level of, let's say, single molecule force spectroscopy, which is now out there, going all the way down to the level of one molecule, few water molecules, let's say, all of these problems where we go away from a continuum picture to a discrete
mm,
molecular level picture, measurements were lacking at room temperature. And I think this is where this branch of stochastic thermodynamics and
mm,
all of this is coming, because these experiments are done at room temperature. There's no escape from that fact, and yet done at the molecular level. And this really then makes the language of physics also different. And I guess this is the important, this is the things that are on my mind nowadays, to to make experimental protocols. So a couple of experimental protocols to study molecules, single molecules, right, at
mm, mm,
precision of one molecule at a time. And these protocols are there. We have built new protocols of measurement, and for which there is no, it's only empirical addition, to the data in a way. But there are no full theories. And current interest in the lab is also to develop analysis mechanisms to separate out contributions, really look at what you want to measure, and then with the protocol that we have sort of established, see if we can uh, develop stochastic thermodynamics theories to analyze the data to begin with, to make sense of what it is. Yeah, so this is,
wonderful.
yeah.
Yeah, that's one of the things I always was interested to know more about is your urge to build instruments. It's something which we have discussed. Whenever we actually talk, we discuss so much about this. We have also a very good grouping of people in our department, and of course IISER, but also within physics department in the H cross, which actually is the
Right.
name of the building in which we
Yes.
work. By the way, I should mention explicitly, Shiva was the one who named that building as H cross.
I
I'm
wanted it to be H bar, by the
H
way.
bar.
Professor Ganesh said no bar. It is H cross. I know it is H cross. I said, okay,
H
fine.
cross, for people who do not know, H cross is Planck constant with a divided by 2 pi. So H divided by 2 pi is actually the H cross or H bar, what we generally use in physics. So if you come to IISER Pune, you'll see that building with the H bar symbol. And that's a kind of a landmark building, part of the IISER Pune. So, Shiva, this culture of building instruments, this is something
Yeah,
which we
in H
strongly,
cross, I must mention every lab is doing this. Every lab is
yes, yeah,
building something or the other. I
something or
think
other,
something,
absolutely.
something.
Absolutely. In fact, that culture has percolated in, and we take a lot of pride in doing that. Of course, Uh, the other aspect I wanted to know is, given that your experience of interfacing physics with biology, that is something which, for example, a lot of students and others might be interested in, because it's one of the frontiers of science, not just in physics. The interface of physics and biology is turning out to be one of the outstanding kind of challenge in terms of looking at how life evolves, both at molecular scale and even at a larger scale, all the way up to ecology and environment kind of weather, even to that extent, even weather. So, Shiva, give us a gist about that interface. You had a very strong footing in physics, but you also transformed yourself to do something at the forefront of biophysics. What has been your experience from a physicist viewpoint? Because of course, there are of course other people like Chaitanya, our colleague, who come from a biology viewpoint and look at biophysics. Very interesting way of looking at things. So, give us gist of about that aspect.
Yeah, so I guess biology is also at the scales in biology are,
Mm,
is across the scales, from nanometer where the ribosome is churning out proteins, for instance, and all the molecular machines working at the level of 1 nanometer to 5 nanometer,
mm,
to the level of cell where microns or so, and then you have an tissue, then organism, and then as you said, ecology and whatever. So the scale in biology is pretty much similar to physics. We
mm,
are talking from quarks all the way to maybe in terms of number the scale is a bit larger, but in terms of complexity, biology I think is much much more complex.
complex, yeah, yeah.
And so if you are a physicist and you're really thinking that and biology triggers your interest, let's say whatever scale that you're working at, length scale, let's say, we happen to work at nanometer length scale, and some people may use tools which are at the scale of micrometers and so on and so forth, or some people may just have the observational tools
Mm, mm.
and interesting observational tools, because physicists are have been doing observations since what, Galileo's time.
Yeah, yeah.
I guess ecology, for instance, is we have example, right? We have our department. So so people I mean so if you are so biophysics is very is vast. So what I am doing is making this precision measurement at a
Mm,
single molecular level, and try to make sense of why certain mutations in molecules will lead to malfunctioning and disease and problems. So that's one aspect of it. One can also look at a cellular level and see from the physics viewpoint what are
mm,
cells, for instance. I mean, there's another question that we are also interested in is kind of we have a classification scheme of materials, right? We have solids, liquids, and gases in physics, and so these are states of matter as we call them, and further we have viscoelastic solids and other things. So if we really look at biological material, which is a living material, and we really ask this question, where do I put this? Is it a gel? Is it a glass? Is it
mm,
no? Because this classification scheme is very very important, I feel, because just by knowing the material belongs to this class, a lot of generalization can be done. See,
true,
for instance,
true.
now if I say cells are gels, or no, no, not cells are not gels, cells are glasses, or one say no, no, cells are just standard linear solids. Just by categorizing it, you sort of will get interesting sensitive parameters to perturbations, and sensitive parameters to say if the cell is doing well or not doing well, and things like that, which are of course of interest to biomedical community. But
Mm,
from physics point of view, these are the interesting questions. Of course, as I said, the stochastic thermodynamics question as to protein that's folded in a structure, it's sitting just below kT in a way, and then it cannot be very very well below kT, because it is so hard then to make it do something else, right? If it is protein is doing a job, it has to change shape, and it has to have elastic constants, it has to have viscosity in order to arrest the flow of
mm,
the material. All of this, even by just making measurements, you can get a lot of important information about the dynamics of life in general.
true,
It's
true.
one of the problems that we worked on was the Hydra somersault movement.
Mm,
we applied full physics principles to get to the bottom of it, how this is kind of as remarkable, substratum walking for such an early animal. How is it facilitated by principles of mechanics? Okay, and I guess this is interesting area, and many people. Bob Phillips has
Mm.
written an article in Physics Today, right, about
Yeah.
how energy scales are coming together at thermal scale when you have a nanometer size objects.
Mm. Mm.
And I guess the life is evolved from there. It is very nicely changing mechanical energy to chemical, chemical to electrostatic, and all kind of energies. If you have a 1 nanometer scale object, all these conversions happen smoothly because all of these energy scales are crossing each other at thermal energy. So this
Mm.
is
Mm.
something that very important observation that has been made in this Physics Today article. And I guess uh, I guess more and more physics uh, experiments uh, at the because we are obsessed with nano physics experiments
Mm.
only for quantum dots and things, but we tend to forget that the molecular machines in our body are doing this nanoscale operations, and we have quantum mechanics, of course, to describe quantum dots and nanoparticles, and but if you really think about electrodynamics, statistical physics, to tackle uh, uh, nanoscale entities, I think there's lot to be done even for theoretical physics. And rightly so, a lot of theoretical physicists are interested now in these problems. I'm not even going to this another scale, active matter, where
Yeah. Yeah.
it's another level of investigation in it. So it's quite hot nowadays, I feel. By
Mm.
the Academy of American Academy, they normally uh, look at what areas are number of PhDs produced, and biophysics is now coming up quite high.
Yeah. Yeah. You're right.
Econor, nuclear physics, and other very old classic areas of physics. It's overtaken it already. So yeah, it's interesting times for
Yeah.
us to do biophysics. Yeah.
Absolutely. In fact, I should mention that within among the grouping of IISER Pune, Shiva, Apratim, Vijay Kumar Chikkadi, Ushashri Roy,
Yes,
and my own group, we have some kind of a subgroup of soft and living matter kind of stuff, and the kind of interaction. And we have seen that there's so many interesting new developments which are happening. And couple that with, let's say, statistical mechanics, let's say Arijit and other people from our own department, and of course outside India also there are so many good groups which are doing stuff. Within India also, this whole thing is actually growing a lot.
yes,
It's a great interface between physics and biology, and it is in the frontiers. For example, neuroscience at a very deep level also has computation, physics, and
yes.
other things. There's also physics of cancer, which
Right.
is such an important area of research. So, Shiva, you've given us a very nice gist of a lot of things. What are the current and future plans in terms of the research? What are you now looking at, and what are the questions you are now exploring going forward? Give us a brief gist about that. Yeah.
So at the moment, we are focusing on two things. One, at the level of single molecules, as
Mm.
people have done a lot of measurements on single molecules, thousands of per year almost. And so our interest is to probe something that has not been probed yet. And this is measuring elastic and viscous components of a folded structure of a protein. So, and this is challenging because this is if you got a protein that is the size of 5 nanometers again, and if you want to perturb this ever so gently, it will be a perturbation that is in picometers. Okay, so forces involved are piconewtons again. So you provide this perturbations of piconewton forces to the molecular entity, and then measure picometer deformations produced in it.
Mm.
Yes, we have done successfully on two proteins so far. And what this allows you to do is what people did before was that take a protein, mechanically pull on it, single molecule level, and it's a quite brittle process. For a long, nothing happens, and suddenly protein unfolds. So it's like breaking a glass. Load it, load
Mm.
it. break it. So this is a brittle process in a way, but that's not how it is. Before unfolding, before having this brittle, you could actually deform protein, and you can measure the deformation. It was because it is like in picometers, it was not accessible so far. So our current focus is to build instruments to measure this extremely tiny picometer deformations in protein directly, which AFM so far was not able to do, because AFM's deformation of the protein, the bending of the cantilever, the technical details. I
Mm,
don't
mm,
go into there, but the quantitative estimate of how much the single molecule, such as 1 5 nanometer size protein, is deformed by, was not done so far. And we have built this interferometer AFM now to do this. And currently we are focusing on many other systems, and this is the first time probably you will be able to have a report on all classes of protein, let's say globular proteins, where you can deform them by very tiny amounts and measure force required to deform it, let's say, and that gives you elastic constant. Also we can measure how much lossy the protein is, the viscous part. So viscoelastic characterization of single uh, proteins is one focus of the lab. The other one at the another scale, which is like 1,000 times bigger, and that's the scale of one cell at a time.
mm.
And this is what is our observation, and the general consensus is that the cells are like glasses. So they follow glass physics largely, at least when we mechanically probe them. And we are interested in finding out the power law exponents of the cells which are sensitive to disease conditions. And this can become a very good diagnostic tool and this is something that people are interested in for a long time, and we want to do that. And third, I guess what we have, I realize now over 15, 20 years, we have a tremendous knowledge in the lab about building these precision instruments.
Mm, mm.
Now thinking of, the ecosystem is right. There's so many government schemes
Yeah,
nowadays, incubation centers everywhere. IISERs, IITs are thinking this direction. I'm thinking to translate this into a maybe a startup, let's say, or,
wonderful.
or an entity which can solve people's problem at the scale of, when the measurement is at the scale of nanometers. And so that's another idea that I have for coming 4 5 years.
Wonderful, wonderful. It's a fabulous idea. I have seen firsthand, Shiva's lab building so many things, so many good students. I have also interacted with many of them, learned a lot from their sitting in their comprehensive exams, PhD theses. Okay. Like Ajit. Ajit is one example who is an excellent student. There's so many of them who have graduated over the years. So Shiva, I want to also diversify a little bit before we end, because I know you have a lot of other interests. I
Okay.
should mention Shiva prepares one of the best biryani among
Yes,
anybody I am actually aware of. He's an excellent cook, and he's also an outstanding person with very strong sense of aesthetics. Jayanti, as I mentioned, Shiva's wife, actually is an outstanding artist, painter. I assume the
yes,
paintings
yes,
behind you
yes,
are from
yes, yes,
Jayanti.
yes,
One
yes.
should look up. Jayanti is actually an accomplished pro artist. Huh? If people are interested, one should explore about her work. So, Shiva, that I also know that you're very deeply interested in aesthetic aspects. For example, you lived in Spain, and I also lived in Spain. That's also one of the point of a lot of discussions which we have. It's a fabulous country. Like
Yes,
kind of anybody who lives in Spain has that impression. I've seen that
yes,
talking to so many people. Give us that gist, because a scientist is not just
yes.
a prototypical person or some kind of monolithic, but they contain multitudes. And
Yeah.
give us a gist, your passion for cooking, for other things also.
I think the passion for cooking comes from my mother and my mother's side of
Oh,
the so I must mention that first. And then when staying out of home, you always have to cook, right? Once in a while.
yeah, yeah.
This really became important when we doing PhD and stay, sharing an apartment with other friends, other PhD students. And that's when we sort of
Mm.
started cooking more and more. And once you are abroad, you have to do even more cooking, right? So you have more time even to sort of experiment and explore. And this is where I guess during the stay in PhD and during postdoc, I
Mm.
made myself sort of a good good cook that you can you can tell the difference between carefully. So that's one. And lately, I think it's all a science of proportions.
Mm.
It's even doing research in the lab, doing music. Even I see
Yeah,
art,
yeah.
cooking. I constantly keep coming back to this theme that this is all proportion, all proportion.
Mm.
You have to, even music, you have to play notes in proportion. All of them sound with equal intensity. It's a bad piece of music. So I think this is also in while doing science, you have to. Um, the most important thing in science is to ignore the mess and focus on the essential. Same thing with, if you really apply that principle to many areas of your activity, I think everything that you do turns out to be excellent. I feel okay.
Absolutely, absolutely.
It's just getting rid of clutter in whatever is happening around you. So yeah, so cooking, yeah, of course you tested my
Yeah, yeah,
a
man.
lot of. I like to invite people over, and the other interest I have is of course literature, as I said.
Literature. Yeah, yeah. I know
Uh,
you also like
Early years it
reading.
was only Marathi literature, and
Yeah.
later on I read a lot of Orhan Pamuk is my
Mm.
favorite. Also, a couple of writers from Spain and South America. So yeah, of course, this is something I think very important activity, the literature reading. And yeah, I also wrote poetry in for a year or so
Nice.
in Marathi. Of course, this is lying somewhere now. I haven't looked.
If
Just one.
I'm correct, if
Yeah.
I'm correct, you are also in a movie, right? You also
Oh
have
yeah, yeah,
appeared in
small,
a.
small one. So
Yeah,
yeah,
yeah. So we have a.
that's just
Pratik
they
has
just
the first
they
movie
just
star.
grab me for doing something. But I think the poetry thing I wrote once. I also got a award in IISER's poetry competition.
Oh wow. Okay.
At
Yeah,
one
yeah.
time
There
I
are a
had
lot of
written
people.
around Corona time. I had written something,
Yes, yes.
and I wrote by some another name. So this is announced, and I didn't tell it to anyone.
Mm.
But yeah, so these are other interests in life, and of course, uh, farming is close to my heart.
Mm.
I get this newspaper called Agro One, uh,
Mm.
which is, I guess, in Asia, this only newspaper devoted to agriculture is Marathi.
Oh,
And
it's made in Marathi. Wow, that's
yeah,
nice.
this is
Mm.
Sharad Pawar's brother,
Mm.
Pratap Rao Pawar, is the edit. Is the one who started it, and it's a very good newspaper. It has,
Mm.
if you want to keep these two newspapers side by side, the normal newspaper and this one, you completely different perspective on every news. That's something that this is one thing that is interesting. But besides, we have a farmland, we have animals,
Mm.
and I have to keep looking at what all is happening. Yeah, I must tell you that we with the sugarcane that we're going to go planting for this season, we'll take AI help
Wow.
to enhance the yield. So these are the kind of things that keep happening around you. Spend like half an hour every morning talking to
Mm.
people farm to see how things are going. Yeah, so I mean, it's just not, as you said, people have this notion that the scientists are this people who sit inside a room, closed door,
Yeah.
and just and think, and nothing happens. I guess that way. I think it's very important that you have a lot of interest in life and a lot of interaction with people. This is then only I think it's quite fulfilling. Otherwise, it will be tedious to think only.
Absolutely, absolutely. Such an important point what you're mentioning, because so many of our own colleagues, so many the kind of rich talent. In fact, it's a myth that scientists actually are sometimes only
Yes.
oriented in one direction. Probably the public perception generally is like that,
Yeah.
but it is anywhere close to the truth. In fact, it's the other way around. So many interesting.
Yeah.
So, Shiva, finally, any recommendations, any books or art, music? Because I know you also like a lot of music, and it's anything which comes to your mind, which you think our audience would be interested in to just know. Not just only science, of course, science we have
Yeah, of
discussed.
course.
Uh,
So,
anything which you find very interesting while reading, or anything you can mention.
right. As I said, Pamuk's, I'm currently reading one of the Pamuk's book that I haven't read so far.
Mm.
I like Pamuk, so I will. John Steinbeck, another writer, I
Hmm.
read.
John Steinbeck, yeah, fabulous, fabulous author. Yeah.
Yeah, so these two writers, I think I've read almost everything from them. So that's one thing. I guess in music, when we were in Spain, I was going to this Casa Cultura de Andalucía in
Wow. Okay. In Madrid, right? You were in Madrid. Yeah.
yes, and
Yeah.
there we used to take flamenco lessons. So learned flamenco for 3 years almost there, and nowadays it's of course gone. Not so flamenco music, of course, is something very very interesting, and it is like Indian classical music. It's confluence
Hmm.
of many cultures: Arabic, the European, and the gypsies who traveled all over
Yeah. Yeah.
they have collected everything from even China.
Hmm.
And flamenco is, you suddenly feel that you're getting some Chinese music. Suddenly you feel
Hmm.
maybe completely. Suddenly you have notions of, Rajasthan, Indian classical.
Classic.
It's really amazing the way flamenco is structured, and it's thousands of years, of course. So that's one recommendation. Of course, jazz blues people know. I mean,
Hmm.
that's,
Hmm.
that's something that people know. But flamenco, I don't know if people have tried. I will really
Yeah.
recommend.
It's generally not much known. I think so in India, but it's so popular in Spain,
Right.
and especially the Madrid part because I lived in Barcelona. Barcelona is a
No, no, there
Catalan
is not much.
influence.
Yeah, yeah.
They have their own
European.
flourish in that
Yeah.
space. Yeah. See, subcultures. There's so many
No, no,
beautiful
no, of
things
course.
within there.
Yes.
Just like dosa in Bengaluru and Mysore is slightly different.
Complete. Yes.
And
Very true.
vada pav in Pune and Mumbai,
And
they also
Bombay.
taste
Yes, yes.
right.
Real,
I
big difference in the
big difference. I've tested both the places.
yeah.
Yeah, I
So
think Pune is better, but of course,
no,
anyway,
paying attention to details is sometimes you're branded as you're doing too much, but
yeah,
attentions are. I mean, if you play attention to these details, it's quite fun. The whole
fun. Yeah.
whole experience about everything, I guess.
Absolutely. It actually adds richness to the intellectual life, so to speak, in that sense. Yeah.
Also, maybe in fine arts, I think I in Vienna, this guy Schiele,
Mm.
not people know about him. He died quite early at the age of 25, I think, right after First World War. His work also fascinates me. I keep sharing on Facebook many
Yeah.
times
Yeah.
whenever it comes. So yeah, that's yeah.
Yeah. Fabulous. Fabulous, Shiva. Thank you very much for your time. It's been an absolute pleasure. So I'll be linking the references to Shiva's group webpage and his other research details. Do have a look, and in fact, you learn a lot more about it. And do contact Shiva in case you are interested in actually knowing more about any of his research aspects and other things. So Shiva, thank you very much for your time,
Thanks
and
Paul for having me.
my
It was
pleasure. Absolutely my pleasure. So this is Pratidwani, where we try to humanize science. This time with the one and the only Shivprasad Patil. Thank you, Shiva.
bye.